Our lesson for today will be about universal sets and subsets. Alright, our objectives for today's lesson are, at the end of this lesson, you will be able to define universal set, subset, and proper subset, and list all the possible subsets of a given set. Okay, let's have an activity first. Consider these cards. We have 1 to 10 of spades. Okay, let us form the following sets using the numbers in the cards. For number 1, set A is the set of numbers less than 5. What are those numbers that are less than 5? Okay, that is correct. We have 1, 2, 3, and 4. So take note of the word less than, no? So you will be considering the numbers that are less than 5. Okay? Next, number 2. Set B is the set of even numbers less than 5. Okay? Take note of the word even. Very good. So those are 2 and 4. Next, okay, number 3, we have the set of prime numbers. Okay, we are going to consider the given numbers, no, or the given numbers in the set of cards. All right, so the set of prime numbers in the given set of cards are 2, 3, 5, and 7. So take note that 1 is not included because 1 is neither prime nor composite. Okay, when we say a prime number has only factors na sarili lang niya and 1. Again, 1 in itself. Okay, number 4, we have the set of odd numbers. From the given set of cards, what are the odd numbers? Very good. Those are 1, 3, 5, 7, and 9. Number 5, the set of numbers from 6 to 10. Obviously, the elements, no, in set E are 6, 7, 8, 9, and 10. Alright, the set of cards which contains 1 to 10 of spades na pinagkuhanan natin ng elements to form different sets is what we call universal set. Okay? Universal set in general terms is defined as the set of all objects under consideration. A universal set is a set that contains all the elements or objects, no, of the other sets, including its elements. It is typically denoted by capital letter U. Alright? The exact definition of U is based on the context or theory being considered. The elements contained in U may vary according to the context of sets being stated. So for instance, we might describe U as the collection of all living things on planet Earth. Okay? In this case, the set of all the mammals, the set of all the reptiles, and the set of all the birds become a subset of U, okay, part of the universal set. Similarly, we can say that the set of all countries in the world is universal because those countries are part of the universe, okay, or part of the universal. In mathematics terms or in mathematical terms, the universal set is the set of whole numbers. Okay, depending on the context, this set may also be the set of all the shapes, a set of all the second degree polynomial, the set of counting numbers, and many more. Since a set is a collection of various entities with a common property, no, take note of that, with a common property, the universal set is the collection of all the elements relevant, no, to a specific subject. It could be anything like real numbers, a deck of cards, just like what we have, no, in our example, the world's inhabitants, etc., etc. Elements in a universal set are not repeated elements. So, all these elements are distinct and unique. Please take note of this. All these elements are distinct and unique. So what happens if we take out some elements from this collection and form a subgroup? Is this is this subgroup meaningful? Will it have any unique properties? What can we call it? Alright, these questions can all be answered by the concept of subsets. What is a subset? Okay, as the name suggests, it is a subcollection of any set. Alright? A subset is part of a universal set. Okay? It is a subcollection of any set. Okay, let us assume we have two sets, set X and set Y. Mathematically speaking, X will be a subset of Y if and only if all the elements of X are present in Y. Okay? We can also say that X is contained in Y. Alright? This relationship is called inclusion or containment of X in Y. Alright, so to understand it more, consider you have a set A, okay, such that A includes the names of all the cities in your country. In that case, a set B comprising the names of cities in your province will be a subset of A. Okay? This is because all the cities in your province must also be cities of your country. Therefore, B is a subset of A. Alright? There are only a certain number of distinct or unique subsets for any set, so the rest are redundant and repetitive. Okay? In other words, if A and B are unequal, or in other words, the following, no, we can make subsets out of the universal set, meaning to say, we can say that A, B, C, D, and E are subsets of the universal set because each element, no, in each set can be found in the universal set. Say for example, in letter A has elements 1, 2, 3, 4, which can also be found in the universal set. Set B has 2 and 4 elements, which can be seen in the universal set. Same with C, D, and E. All elements are found in the universal set. Do you understand? Okay, very good. Okay, a subset is denoted by this symbol. Take note of this symbol because this symbol is important in dealing with subset. Okay, if and only if every element of set A is also an element of set B. Alright, we can say that set A is a subset of set B or set B is a subset of set A if all elements, no, in A can be found in set B. Meaning to say, if they are equal sets, alright? If they are equal sets, we can say that set A is a subset of B or B is a subset of A. Okay, let us consider set V and set W. Set V contains A, B, C, D, and E. W contains A and E. All elements of set W are found in set V. Okay? Such as A and E. A and E, which are found in set W, can be seen or can be found in set V. But not all elements of V are contained in W. Di ba? Wala namang pong B, C, and D sa W. Now, if W is a subset of V, but V is not a subset of W, we say that W is a proper subset of V. What is a proper subset? So what is a proper subset? A proper subset is denoted by this symbol. As you can see, this is the same as subset pero wala siyang guhit sa ilalim. This symbol is not underlined. Okay? If and only if every element of set A is also an element of set B, and set B contains at least one element that is not in A. Okay, a proper subset of a set A is a subset of A that is not equal to A. In other words, if B is a proper subset of A, then all elements of B are in A, but A contains at least one element that is not in B. Okay, let us consider these sets. Set A contains ABC and set B contains ABCD. We can say that A is a subset of B, okay, a proper subset of B, since each element in A is also an element in B, and there is at least one element in B that is not contained in A. We cannot say that B is a subset of A because D, no, the element D is not an element of set A. Okay? Wala namang D sa letter A. Okay? We can say that A is a subset of B, pero si B hindi niya subset si A kasi wala naman pong D kay A. Hence, B is not a subset of A, but A is a subset of B. For example, if set A contains 1, 3, 5, then B, which contains 1 and 5, is a proper subset of A. Okay? Kasi hindi sila equal. Kaya proper subset ni A si B. Okay? Kasi si B meron lang siyang 1 and 5. Kaya proper subset of A si B. Okay? C, which contains 1, 3, and 5, is a subset of A. But it is not a proper subset of A since C is equal to A. Again, if the two sets are equal, they are subsets of each other. And D, which contains 1 and 4, is not even a subset of A since the element 4 is not found in set A. Alright, consider an empty set. So the empty set has no elements. This means that it is impossible to find an element in the empty set that is not in set A. Since an empty set has no elements, there is none that can fail to be elements of A. Hence, the empty set is a subset of A. Okay? Alright, let's have some examples. Number 1, what symbol is needed to complete this? So set contains 1, 2, 3 is blank to the set containing 1, 2, 3 elements. Okay, very good. Since they are equal, we can say that this is a subset. Number 2, the set which contains 3 as the element is blank to the set with elements 1, 2, 3. Very good. Proper subset. Since the two sets are not equal, we will be using proper subset symbol. Okay? Next, number 3, the set containing elements 7 and 8 is blank to the set containing 1, 2, 3 elements. Very good. It's not a subset. Number 4, 2 is blank to the set 1, 2, 3. Very good. Is an element. So we will be using is an element because 2, as you can see, the number 2, hindi siya set. Wala kasi siyang braces. So, kapag nakita nyo lang si number 2, that means we are talking or we are referring to the element. Since this is the element that can be found in the given set, in the other set, so we can say that 2 is an element of the set containing 1, 2, 3 na elements. Number 5, alright, 5 is blank to the set 1, 2, 3, to the set with elements 1, 2, and 3. What symbol? Very good. 5 is not an element. So this is not an element. Okay, this is not an element. Alright, let's have another set of examples. Fill in each blank with the following symbols. You may pause and play the video kung may sagot na kayo. Number 1, correct. Number 2, very good. Number 3, excellent. And number 4, very good. Number 5, there you go, very good. Apple and banana. Okay, let's add another element to our example set. How many subsets does the set of apple and banana have? It could have apple or banana, and don't forget the whole set and the empty set. So a set with 2 elements has 4 subsets. Okay, how about this? Okay, let's be more systematic now and list the subsets by how many elements they have. So una, the subsets with 1 element, 1, 2, and 3. And list down the subsets with 2 elements, 1 and 2, 1 and 3, and 2 and 3. And don't forget the whole set, the set itself, and the empty set. Okay? So, the first thing to notice is that the total number of subsets doubles. Alright, the first thing to notice is that the total number of subsets doubles each time. A set with n elements has 2 raised to n subsets. So meaning to say, if we have 0 element, that is 2 raised to 0, therefore the number of subsets is 1. If we have 1 element, that is 2 raised to 1, that is equal to 2. Therefore, we have 2 subsets. If the number of elements is 2, that is 2 raised to 2, that is 2 times 2, and that is 4. Therefore, the number of subsets is 4. And if we have 3 elements, that is 2 raised to 3, and that is 2 times 2 times 2, and that is equal to 8. Therefore, if we have 3 elements, the number of subsets is 8.